integer constant in C, we know that set is collection of well defined objects or an elements. There are some standard set. First, set of natural number. It is denoted by this symbol. It is called natural number set, and it contains an elements 1, 2, 3, 4, and so on. Next, set of integers, and it contains an elements in -3, -2, -1, 0, 1, 2, 3. Next, set of rational. It is of the type say p by q. PQ belongs P and Q are integers and Q is not equal to 0. For example, 1 by 2, 1 by 3, 2 by 5, and so on. Or it is also called non terminating or repeating decimal fraction. It is also called rational number. Number 4, irrationals. It is denoted by this symbol, irrationals. And not rational are called irrational, or in other words, it is not terminating, non-repeating numbers are called irrational number. For example, pi, e, under root 2, under root 3, under root 5, under root 7, and last, set of real number set, and it contains the union of rational and irrational. Okay, or in other words, actually n and z are subset of rational. So the real number set contain natural, integers, rational, and irrational elements. So the real number form. So in today we are going to study the integer constant in C. So which numbers are called integer? So integer constant in C. So integer constants are some elements of integer constants are -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. Okay, so what is integer constant? It is without any, it is what, in other words you can say, without any fractional part, any fractional part, or exponent part, or in other words exponent part. Again, it has three types. In C, the integer constant has three types: decimal, its base is 10. This is what, base 10. Then octal, its base is 8. And hexadecimal, its base is what, 16. Now for example, as we know that if we consider an example, say 42 in decimal, okay, here base is 10, we can convert it into octal by dividing this 42 by 8. Then it's what, the remainder is what, here quotient is 5 and remainder is 2. Again, if we divide by it is what, if we divide it by 8, then here the remainder is what, 5. So quotient is 0, so the remainder is what, 5. So if we write this number into octal base, it is equal to what, 52. So the 42 is given in decimal and its octal representation is what, 52. Similarly, to convert 42 into a hexadecimal whose base is 16. Again we are going to divide this 42 by 16. Then it is what quotient is 2 and the remainder is what 10. But in hexadecimal this 10 is denoted by a. Okay, and again if we divide it by 16, it is equal to what? Remainder is quotient is 0, remainder is 2. So the 2a, 42 is what? We can write this 42 in hexadecimal form is what? 2a 16. So as we know that the 42, this number is given in decimal, its octal representation is what? 52, and its here base is 8 and hexadecimal representation is what? 16. Now in C, suppose, okay, now here if we write the simple program here, include std.h, include hash include conio.h. These are some header files, standard input output library conio.h. then next void main. Our program always start from main function. And now suppose we declare here to declare integer variable we use the keyword int, and suppose x is a variable and we assign here 42, then and clear the previous output. Say to clear the previous output we use the keyword clr scr, and then print app %d, since it is an integer, %d, say x, and you will get x is equal to %d x or x in hexadecimal, in decimal is equal to what? X, and what? Get ch. And now if we compile this, error is 0, and if we run, you will get the value of x in decimal is what? 42. Instead of x I am writing here a, variable a. So a. Now if you want to print this value of a in octal, just write down here printf the value of a in octal, that is decimal to octal is equal to, write down %o to print a value in octal. And if we run again this, you will get it is what? 52. So we are going to use a new line character. Now if we run again, you can see 52. Okay, and now if you want to print this value of a in hexadecimal, just write down printf the value of a in hexadecimal is equal to percent capital X. If you use capital X, it gives an output in hexadecimal form, decimal to hexadecimal. So if we run here, it is what? 2a. Now you can check here. Okay, so here 2a in octal. What is in octal? In decimal, the it use the digits is what? 0 1 2 3 4 5 6 7 8 9. In octal uses 0 1 2 3 4 5 6 7, and for hexadecimal it is uses 0 1 2 3 4 5 6 7 8 and 9, and for next six digit we use your capital A B C D E F and A B C D E F. Okay, so here in C you can print decimal, octal and hexadecimal representation of any integer constant. Suppose if we if use the next number, say here, um, say 60, say 60 or 62, and if we run here, sorry, if we run, it gives what? 62 76 3e. So what is this 62 converted into 62 is given in decimal, so the 62 is given in decimal. Now to convert it into octal, just write down this divide this 62 by 8. So it is what, quotient is 7, and here remainder is what, 6. Then next again if we divide by 8, the quotient is 0 and remainder is what, 7, and so it is equal to, we can write this into in this direction. So it is what, the octal representation is what, 76 in octal. Similarly, so here you can also check in octal we get answer is what, 76. Now the next, if we want to convert it into hexadecimal, just if we write here 62 and if we divide by 16, then it is equal to what, the quotient is 3 and the remainder is what, the 62 minus 48, 62 minus 48 is equal to what, 14, and for 14 we can write, or this is what, 10 11 12 13 14 and 15. So 14 we can write is what, E, right here E, and the next again if we divide by 16, the quotient is 0 and the remainder is what, 3. So the what is hexadecimal representation here, it is equal to what, 3e. Now the next, you can convert this 76 into a decimal also. So to convert this 76 into a decimal, this is given in octal. To convert into decimal, just multiply this 6 into 8 raised to 0 plus 7 into 8 raised to 1. So this is equal to what, 6 plus it is equal to what, 56. So 56 plus 6, it is equal to what, again it is equal to 62. So this is what in decimal. Now next we are going to discuss about the memory of integer constant. So as we know that for integer constant require 2 bytes to store integer constant variable, we require what, 2 bytes memory. Now we know that 1 byte is equal to 8 bit. So if we consider here only 2 bit, in 1 bit we can store 1 or 0. Okay, so there are 2 choices for 1 bit. If there are 2 bit, then you have how many choices? You have 1 0 0 1 1 1 0 0. So you have how many choices? 2 raised to 2, that is 4. Okay, so if it is 8 bits, so we can store 2 raised to 8, which is equal to maybe it is around 60 what, 2 raised to 8 is equal to 2 raised to 8 is equal to 256. Okay, so 256. And now see, this is only for 1 byte, since it is contain 2 bytes. So 2 bytes, it is equal to what, 2 raised to 16. So 2 raised to 16 is what, 2 raised to 16 is equal to 65,000 536. So you can store a largest number is what, 65,536 if it is an integer. But this 65,536 is divided into two parts. Its half is used for positive number and the half member is used for negative number. So the for positive it is what, 32,765, and here maybe 32,760 68. I'm going to divide it by 2, so it is equal to 32,768. Okay, and here 767. So for you can store a positive number up to 32,767 and negative number 32,768. So for example, if you consider one more program, here say include hash include stdio.h hash include conio.h, then void main, and if you write here integer x is equal to say here 30,000, and clear the previous output, and if you print here, since it is an integer, we can associated it is what, %d x. Okay, and get ch, and now if you run here it is what, 30,000. But if you try to print here say 32,600 and 769, then or it prints negative number. We input is what, 32,769, or here if you write here 33,000, okay, it does not give the output. Why? Because there is for positive number it is what, only member is what, 32,767. So now you can convert, if you want to print or store only a positive number, you can convert this negative to positive also. Similarly here for negative you can use the negative 32,767 8 up to 8 you can print negative number, so you can check. But if you try to print a larger number, says 799, then it cannot print. Okay, it gives the wrong output. Why? Because for what is the memory here, the memory for, okay, already I have explained, since integer constant required 2 bytes memory. So how many bits here, total how many bits, it is what, 16 bits. This 8 plus 8. Okay, so the larger number you can store here, it is what, 2 raised to 16. So 2 raised to 16 is what, 65,536, and out of that the half memory used for positive numbers and half memory used for negative number. But you can convert if you want to store only a positive number, you can convert this negative to positive by using the keyword unsigned, unsigned. Unsigned, by using this unsigned keyword you can convert this negative to positive. So for positive number you have total 65,536, and to use unsigned, what we are going to do here, now you can check here, suppose we are going to print store here 34,000, then it gives output is what, wrong output. But if you use here unsigned integer, and here instead of percent d write down here percent u, and now if you try to print it gives 34,000. So but again you can use this, you can store up to six larger number or 65,536 or something. So but if you try to again use 66,666, again it gives a wrong output. Okay, it gives wrong output. Why? Because the the largest is what, the you can store up to 2 raised to 16, that is 65,536, 65,536. Then it gives the correct output 535. Okay, so it gives correct output, but beyond that if you try to print here 9, then it gives output is what, again a wrong output. Okay, so again there is so this you can again expand this integer memory by using the keyword long. Okay, long integer. So it gives, it is what, for for regular integer it is what, 2 raised to 16, and for long integer it is what, 2 raised to 32 minus 1. Okay, this much memory you can use for long integer. So for that, now if you want to, sorry, if you want to print this number, then use here long integer, and associated type is what, percent ld. Then now long, sorry, long. Now you can see you can print up to 2 raised to 32. So it's very large number you can store now. Say you can store say 9999. Okay, you can easily store this number. So this is all about the what, integer constant. So again I am going to discuss here, I am going to write here summary, that is integer contain 2 bytes. Okay, 2 bytes memory, so it is what, 16 bits. So you can store up to 2 raised to 16 minus 1, so it is equal to 65,535. This much memory, this much larger number you can store in integer, but this 65,000 is divided into two parts. The negative, the for negative number it is minus, for negative it is 32,768, and for positive it is 32,767. Okay, for positive. So the range of range, this is the size of integer, the range of integer constant is minus 32,768 to plus 32,767. But if you can convert this into negative into positive by using the keyword unsigned integer. So now it is what, 0 to 65,535, 65,535. And again you can expand this memory by using the long size, by using the long integer, and here you can store integer number up to 2 raised to 32 minus 1. Okay, here it is what, 2 raised to 16, 2 raised to 16 minus 1. So this is all about the integer constant. So